Okay, dear ladies and gentlemen, welcome to today's webinar on RTK Videogrammetry with 3Dsurvey and Emlid. Joining us today alongside with 3Dsurvey team is Julia from Emlid. So Julia, could you please introduce yourself a bit more also, and what's your role at Emlid?
Sure. Okay, so one more hi to everybody. My name is Julia, and yeah, I'm an application engineer at Emlid. So yeah, I've been working at this position for nearly 5 years now. And yes, so I'm part of the support team. I started with the supporting the customers, like the final clients that we have, but now I'm mostly working with our partners, with different kind of integrators, and also help with all the technical questions, issues if they arise, and yeah, this thing. So yeah, that's the main thing about me, I believe.
Very good. That sounds very powerful. A lot of stuff in the same person. So thank you, Julia, for this. Then next, we will move on to the practical part of the webinar, where you will see how this technology works in a real project. This session will be presented by our Ivan Jean, our videogrammetry expert at 3Dsurvey. And last but not least, I will show you the result you can obtain from a simple 2-minute video and deliverables you can achieve using these workflows. And yes, my name is Marko. I'm the product manager at 3Dsurvey. And maybe before we go further, I would just like to start with a quick poll to get some feedback from the audience. And I will just launch the first question, and this one is, are you already a 3Dsurvey user? So you should see the question right now, and you're able to vote it. It's great to get a bit feedback from you. What kind of audience do we have here, that we can also optimize the workflow during the webinar, go maybe a bit more detailed and specific in some parts and so on. A few more seconds, so we can see more than 60% already vote. I will close this first question down, 3, 2, 1, and I can share also results with you. So we can see 40% of existing users already, 33% not yet, and 27% are thinking to buy the software. This is always great to hear. Thank you for your answers. And let's switch to our next question, which is, just a second, do you currently use RTK Videogrammetry as a part of your regular workflow? And the answers are yes, not yet, or I will try after this webinar. So it's still a new, exciting technology, super powerful and quick site documentation and so on. But let's see what kind of answers are we going to get here. Okay, you're very quickly, more than 60% already voted it. And I see we still have a lot of potential here. I must say we get a lot of feedback on support about the RTK Videogrammetry, because in some cases it's still kind of super tricky, but don't forget, you always have support option. We can teach you how to do it and so on. Okay, most of you voted already. I will close the poll and share results with you. And we can see that 13% are using this mainly on a daily basis, 51% not yet, and 36% will try after this webinar. So I would say great audience. We will try to convince you that you need to try this out. But of course, it also depends what kind of projects you have and so on. Okay, and let's go to our third question. So third or last question, are you already using Emlid devices in your daily workflow? And two simple questions, yes and not yet. So we've been testing a lot of devices really much, especially with the RTK Videogrammetry, and I must say Emlid is one from our top one, because it's so easy, super easy to use, and because it's so stable. So you turn it on and it works. So not a lot of settings needed and everything like that. This is what's making this device super fascinating for us. Okay, also more than 70% voted already. I will stop the poll and share results with you, and I think we have really nice results. So 46% of people are already using Emlid devices and 54% not yet. So the ones who are not yet using, you will see the power of this device, and the other ones, they already know probably most of it. Okay, thank you for your questions. Thank you for your answers, and let's continue with our presentation. So we always say at 3Dsurvey that 3Dsurvey is much more than just photogrammetry software, and we can see nicely this presented on this graphic. So we are trying to integrate a number of different devices. We are supporting a number of different technologies. So you can see it here, drone mapping, where you can quickly calculate the volume calculation or extract CAD data. You see the RTK Videogrammetry, you see the SLAM technology, which is now super powerful. You have drone lidar, bathymetry, and all this stuff. And everything you can merge, you can join, you can process in the same software. So this is something very special about 3Dsurvey. But today, what I would like to focus on, and of course also Julia, it's RTK Videogrammetry. So, and what actually is RTK Videogrammetry? It's actually a fast and reliable site documentation tool. It's a perfect tool for documenting of various construction and engineering projects involving pipelines and underground grids. It's actually convert 2D videos in 3D model. You will also later see this on a real example. And you can do all this with a super affordable equipment. So probably you can use your existing Android phone. You add to this Android phone external GNSS antenna like Emlid RX. Maybe you already have it. And then you just need additionally software for processing all this, and that's it. You are ready to go. And now I'm giving the word to Julia to present about a bit more about introducing Emlid and so on. Okay, feel free, Julia.
Thank you, Marko. So yes, let me start with giving you a bit of context of Emlid. But it was really cool to see that so many of you actually are already familiar with us. That's great. So at Emlid, we do produce the satellite receivers, the hardware, and also the software for them to actually go and do the measurements for land surveying, for construction, and for many other industries. So we've been working with it for more than 10 years already. You can see that our headquarters are based in Hungary, in Budapest, and actually that's where I'm calling you from right now. So when we take a look at the devices, you can see in the picture the new ones that we launched just recently in October. You can see here Reach RX2, Reach RX4, Reach RX4 Pro. We also have Reach RX3. And if you're curious about the devices, feel free to check our website as well, emlid.com. Today, we're going to focus mostly on Reach RX and Reach RX2, just because, well, we are using them in the integration together with 3Dsurvey. When we talk about, the applications for the units, so they provide a solution for you to be used in land surveying, in construction, utilities, GIS, and many more, because anytime you need to get accurate position, of course, when you're working outdoors, you can use the satellite receiver. So you just get meter accurate position, and you can use it for lots of custom projects here as well. And but now let's focus on the specific product line just with Reach RX and Reach RX2. Again, the ones we are using in the integration. Thank you for the slide. So yes, what is this different about this product line? Like what's specific about Reach RX? And again, the new device we've launched, Reach RX2. So when we were working on the unit, we really tried to make it as easy as possible, like in use. So the device, well, you can see the screenshot here. It has like really minimalistic configuration. So you just technically need just to configure correction input. So when we talk about the devices, Reach RX and Reach RX2, they are both network rovers, which mean that they can only like receive corrections. So you usually receive corrections with them and then go and do these accurate measurements. So you don't use them as a base and don't transmit corrections from them. Another thing is that like it's network rover, which means that it only receives corrections by the internet. That's why they're also like widely used in urban areas where you have this cell coverage. And yeah, to get corrections here, you basically just need to have internet connection on your phone, because later on you connect via Bluetooth to the receiver, and yeah, it allows you already to get the corrections on the device, again, get the centimeter accuracy. The format of corrections we're supporting, it's industry standard, it's RTCM3. So here you have options how to get corrections. It can be some local course, because, well, most of the course support this format. And also it can be your own base. So here you can use even our own device like Reach RX4, for example, which can be used as a base and provide corrections for Reach RX2 being used as a rover. And yeah, getting back to the design, so you see that like the only thing we configure here is basically enter credentials. You specify them in correction input, and after that you can get a fixed solution, you can get centimeter accuracy, and you can go do the measurements. The device is also ready actually for work in the field, so it's small, it's lightweight, and it has also IP68 protection, which means like, well, it can handle work in real world, in the world of, yeah, well, surveying. And well, yes, so we talked about Reach RX and Reach RX2. Now let's take a look at what is different with Reach RX2. So what has changed, what is new in this model we've just launched recently. So Reach RX2 is all band RTK rover, which means now it has this full support for L5 frequency. And in practice, what it gives you, it allows you to work in more challenging conditions when the sky view is more blocked. For example, in more dense canopy, or in urban areas where you have a lot of buildings around you, which are, well, blocking the sky view for the unit. But yeah, it's still possible to work in these conditions with Reach RX2. Again, do the measurements, get centimeter accuracy. Another big change here is the tilt compensation. So it means that now when you work with the device, you don't have to level it on the pole, so you don't have to watch this bubble. You can use tilt compensation. For that, you'll need just to pass this small like alignment process to activate IMU. And it also allows you to work in more areas, in more spots, because, well, imagine you are getting close to the building. If you need to level the device, you keep it vertical. The most part of the sky view will be blocked in this case. So it's like, it's not the way to work. But with the tilt compensation, you just tilt the device and you can collect the points which are very close to the buildings as well. And well, some things are changing, some things are staying the same. It's still the device that doesn't require the like specific setup or specific training to get to work. You still just configure the correction input. Okay, you also enable IMU to work with the tilt compensation, but other than that, you're just good to go right after. And yeah, well, the thing with the device being ready to work in the field stays the same. It's still small, lightweight. Yeah, you can see that it's like just 280 grams, and well, it just fits in your pocket. And apart from that, the unit also has a really durable battery, so you can see it can last up to 18 hours, well, which should be more than enough for a work day, so it can survive it just perfectly. And well, when we talk about this setup, so you can see here in the picture, the device is also on the survey pole. So here we're talking mostly about collecting the data of the device on the pole, again, land surveying, construction, utilities. But the device is not only like built for that, it can be also used in lots of integrations. And again, that's one of the reasons why we're here, and we are talking about one of such things. Yeah, I think we can move to the next slide. So yeah, that's how the device can be integrated here. For integration with 3Dsurvey, we have this handle where you can also place the device. So it has this standard mount rad, which allows you to just like remove the device from the survey pole, put it here on the handle, and use it together with the phone. How it's working here? So Emlid's part of integration here allows you to get centimeter accuracy for the data you're collecting with the phone. By default, Reach RX2 and Reach RX, well, they both output the position via Bluetooth. So it gets centimeter accuracy and then it streams it via Bluetooth. And then on your phone, an Android phone here in this integration, you can use the mock location feature, which substitutes position of the phone with the position it gets from the receiver. So later on, you can just easily use position of the receiver right in the phone. And you can see that this offset of the receiver relatively to the phone is fixed. So it's always the same value, the same offset, it's also considered. And well, with the photogrammetry, like videogrammetry, which is more correct, yeah, here, you can get this point cloud, you can get this data collected and processed together. With the receiver, you can accurately georeference it in the space, so know where exactly it is located, again, with, well, centimeter accuracy. And, well, what can I mention here as well? Yes, this thing is like, okay, we talked about the handle and the devices placed on it, so it has this command thread there. But again, well, for example, you're collecting GCPs for your scans as well. It's also possible with exactly the same device, so you just like unscrew it from the handle, put it on the server pole, do the measurements, and well, if needed, return it back. So it's like it still gives you this flexibility, and you can use the device for many purposes. But I believe, yeah, you guys will cover it regarding the GCP's collection as well with the 3Dsurvey. So yeah, I think I can give the floor back to you.
Very good, thank you, Julia. I can just confirm everything what you explained it already. Okay, so one more maybe beneficial thing which we figure out when we compare it all other devices. So with the Emlid device, we can get, I believe, 5 positions per second out from the mock-up location. And this means 5 positions per second, and this is super good for our videogrammetry algorithm, because with most other devices we were able to get 1 or 2 per second. Okay, so this is this just gives you a higher accuracy even if you are moving faster during the recording of the video, and it's kind of super important. And I could say also the pricing range of this RX, it's brilliant. Okay, it's still not too expensive if you ask me, so for surveying customers it's no-brainer. Okay, Julia, thank you again for this, and yes, we prepared also a super interesting part captured on the field with our Ivan Jean. So I believe it's a 4 or 5 minute video. You will see the field data acquisition with the device and 3Dsurvey SiteScan app. So we designed also a special app for recording videos, where we take the position from the Emlid RX device and write those positions during the video recording. There is also a second option in the same app, is you are able to record also ground control points in case you need it. All this you will see on a video. And again, kind reminder, if there are questions, write them during the webinar, don't forget. Okay, and now I will start video play and see you in 4 minutes. Okay, so first this one.
Hi, my name is Ivan. Today we'll be using Emlid Reach RX combined with our 3Dsurvey SiteScan app to document the construction site behind me. As you can see, a new heat pipe is being installed. To ensure that we have a really precise and accurate results, we'll be also measuring 5 ground control points. We'll be using April tags as our software recognizes them automatically.
Okay, as Ivan already explained, first we need to lay down the ground control point targets, in this case April tags, because they are automatically recognized, so no manual work during the orientation step in 3Dsurvey. Of course, we need to place them before we do the recording, because ground control points, they need to be on the video and later on extracted frames before we are calculating our 3D models. In this case, we'll place 5 ground control points because the site is not too big. I think it's about 100 or maybe 80 meters long, and we spread those ground control points equally to the complete site. So everything what's actually inside of the site, inside of the ground control points, should be super accurately. From our experience, actually, if we do the measurement without ground control points, so just with the video recording in 3Dsurvey SiteScan app, we can achieve accuracy in 10 centimeters, something like that. If we additionally measure ground control points, we can go to centimeter accuracy with the orientation. Okay.
So as you can see, I have spread the April tags across the construction site approximately equally, so we are covering the whole terrain. Now let's get to the recording part. First, we need to power up the Emlid Reach RX. While it's booting, I'll go to the anti-RIP app on our phone. We'll see the device is ready when the white light stops blinking. Okay, the device is ready. Make sure you have Bluetooth connection enabled and click connect. Okay, we are connected to the device, and now we need to wait so we get RTK fix. This will be also indicated by the green light on the Emlid Reach RX. Okay, so we have reached RTK fix, also indicated by the green light on the Emlid Reach RX. We have approximately 2 centimeters of 3D error, which is really optimal. Now we will move to 3Dsurvey SiteScan app. Okay, so on the left side of the screen you can see the horizontal and vertical accuracy. Also we can see that the vertical accuracy is 2 centimeters, which is optimal. Now we'll create a new project by clicking the button in the middle. It probably has the name of the previous project written on it. And creating a new project by clicking on Create New Project and writing the name. I will name it Heat Pipe 2. When we are done, we click Confirm. Okay. So now we are ready to record the video. I will place myself on the start to the start of the path and start filming by clicking the big red button.
Okay, Ivan is now recording the site. As you can see, there are always some tricky scenarios. We had a high fence here, so he need to hold this device a bit higher up. What could happen even additionally is we would place this device on a stick, or we will immediately have camera position 1 meter higher and better perspective for 3D models, so the end results would be even better then. But even with this technology, he's just holding his head up, walking like so. He's trying to keep the main focus of area in interest in the middle of the camera view, and that's it. Currently, I believe this is going to be 1.5 minute video, and later on you will see how we can transform this actually in 3D. Now, when he's recording.
So I have finished the recording. Now we'll move up to measuring the GC piece. We'll use the same Emlid Reach RX device and our SiteScan app, but we will move the GNSS rover to our pole right here. Let's get to it.
So as Julia mentioned it, you simply dismount from the hand holder and mount it to a pole. I think we preset here 2 meters pole height. So, and it works like a traditional GNSS device.
Okay, we are ready. So now, to measure the points, we will click the point measure button on our app, located on the bottom right. And we will have to do a few things. First, we will choose our point name. By default, this will be 1, which is perfect for me. Then we will choose our antenna height. For me, this will be 2 meters, which is also the default value. And record duration, I will choose 20 seconds. But you can stop at any time of measuring the point if you want. Now, let's get to it.
Okay, and we are collecting now point by point. When you're measuring it, this is still the Reach RX model, so you need to look at this bubble that's in the center, that the pole is vertical. With the new model, even this is not needed anymore.
Okay, so we are done. We have recorded the video, we have measured the points, so now all that's left to do is to share our data to the colleague in the office. We can do this by clicking the menu button, selecting projects, selecting our project name, selecting everything in it by long clicking on each thing, and clicking the upload button in the upper right. Okay, so that's it. We have shared the link to our data and we can return to the office. Thank you.
Okay, very good. So first video is finished. Hopefully you have good imagination how this works on the field. Shouldn't be something hard. What I would like to emphasize again, so in this case, we were going super accurately. Beside the telemetry videogrammetry, we also use the hypertext for orientating everything. Definitely this helps to improve the accuracy of the end model, but in most cases probably it's not necessary. So if you just need quickly something to document it, you just record the video and process the data. Okay, and you get accuracy in a global position up to 10 centimeters. If you go to centimeter level, then you can do it additionally with the ground control point targets. You can use any detail points, but if you have hypertext, you will see in the next step the workflow is fully automatic because also the GCP targets are automatic centered. And I believe we are ready now for the second video. So where we will show you how we are able to process videos, so 2D video into 3D models. So it's a bit longer video, but yes, super interesting. And see you in a 12 minutes or something like that. Julia, would you like to add something in between before? No?
No,
Okay.
all perfectly covered. So yeah, I really like small details regarding these changes with the research.
Okay, very good. So then let's start with our second video. I'll see you in 12 minutes. Okay, we are back from the field, ready to start with the processing in the office. I already copied the data from the mobile phone, my Pixel 8 device. So what I downloaded from the device via cable connection is the video. I recorded with 3Dsurvey SiteScan. It's a special file because it has also written telemetry position for every frame or even more. And if I double click, just to remember how it looks like. So this is our area of interest, heat pipe. We record it like that. Because of high fences, it was quite difficult. We could use maybe additional stick to place the camera a bit higher and pointing maybe a bit more down, but nevertheless, let's see what we get out of this one. So on construction site, fields, and there are always tricky conditions and everything like that. Okay, cool. cool. Let's stop this file. The another file which I copied to my project folder here is the apertex, which were measured actually with Emlid RX device and with a SiteScan app. So 5 points with coordinates, geographic coordinates here. We will transform them later in 3Dsurvey software. Okay, cool. Let's close this down. I will just copy the way to my project folder, and here I can already see 3Dsurvey 4.0 open, and instead start with a new project where I'm importing the images and starting the photogrammetry project. Processing, I will start here with images, extract image from video. So if you are doing RTK Videogrammetry, go to images, click on extract image from video, browse to your project folder. I will just copy it here. You can immediately see video, record in a field, open it. Then we have here four different types for extracting out the frames. Automatic means that we look for the next frame where the image changes for a bit more than 20%. This is kind of a super nice one, but takes the longest one because we need to process it. That's why I usually decided for frames per second, FPS option, and I just defined 2 frames per second. This will give me, in this example, 140 frames. Probably the video is 70 seconds long, and this means twice it's 140 frames. Okay, I will click on OK, start extracting all these frames from the video. Right now, we are checking also for the best GNSS positions in between, finding the best frames, combining them with the positions, and this will take probably a minute. And let's see the result of frame extraction. Okay, it took us a bit more than a minute to extract these 140 frames. We immediately came into the telemetry important window. Here what you need to decide is just define your right coordinate system because we are in Slovenia. This is already predefined. Otherwise, just write it here, Austria, and you will get the most important preset immediately, or custom, and define your one you like to have it. Okay, I will go back to Slovenia, and we have horizontal, vertical coordinate system, and also geoid file immediately. I will click on import. Data was successfully imported. In this window, we can nicely see also every image coordinate written from telemetry, the height based on geoid model, and also accuracy, e-precision, north precision, high precision. We see we had good accuracy with Emlid device all the way, and I will just click on close here. If you like to be even more precise, you can enter here the GPS NSA offset between the devices. You can find out more in instructions. In this way, I will skip this because I use the ground control points as an apertex, and it will eliminate this displacement. So I handle this without also if I have ground control points. Okay, so let's click on close. And if I click here in telemetry window, I can see how I was actually moving with my data acquisition. So here every camera means image position. If I click on image and click on my first image and move with keyboard down, you can see which frames we actually extracted. So this looks quite good to me. We also recorded apertex here. We have them on frames. This is super important. Otherwise, you can't do the orientation with this. Okay, and now I'm ready to start my bundle adjustment. So I would like to bundle all the images in the same model. That's why I'll click bundle adjustment, and I will just confirm the default settings with OK. This will now take probably 2 to 5 minutes, depends on your computer setup, and we are back in short. Okay, here we have the results of bundle adjustments. So you can see so-called sparse point cloud. Down here are camera positions. I can turn off the text to see it better. We can clearly see the way where we were walking, and this looks all fine to me. Next step is to do the orientation. I will click the orientation button, orientation with GCP data. And here I need to browse to my hypertext GCP file. Here it is. I will just open it. Make sure that you preset here things correctly, because in 3Dsurvey we defined the Slovenian National Grid Coordinate System already, and here we have GCP measured with latitude, longitude, altitude coordinates. So this is geographic coordinate system, and that's why I need to define here my right coordinate system. So I believe the EPSG code for Slovenia is 4326. Now I'm ready to import it, and I can see already the coordinates in my Slovenian coordinate system. And what I need to change here, I don't have no 3Dsurvey targets, which are black circles or white plate. I have hypertext. And this means in the next step, when I click here, every image will check for the hypertext and we automatically detect them. So you are not going to need to manually click on the images and show where the targets are. Everything does the algorithm for you. So 3Dsurvey will find those hypertexts and give you the position of targets in the next few seconds. Okay, so here we can see on every frame where those targets are. If I zoom in, here is hypertext point 1. You can see the minimap here, so this looks all good to me. Quickly just check all others. That's all fine. So also the estimation GCP errors are fine. I will click next, and now we get the result on images. So the GCP one was on, let's say, 25 images or something like that. The software automatically center it right in the center, where is the center of GCP of the hypertext, and immediately eliminate the images on which were too far away, or maybe the resolution is low, or the target was not bestly visible. So this is more than perfect results. If we have, let's say, 10 images marked with the GCP position, it's more than enough. So you could correct this and place it better if you need it, but I can see the detection works perfectly in my case. I will just confirm with next, and now the complete orientation for the bundle adjustment is running based on my GCP locations. Let's wait a minute to get the results. Okay, here we can see, because we have enough of ground control point targets, not big model, we have accuracy of the orientation within 1 centimeter. I will just finish it, and we can immediately see our model is our videogrammetry model is already orientated with the ground control points. We could work also without any ground control points, so that we would just use the telemetry data which we recorded with the external RTK antenna, Emlid RX. In this case, we'll probably get relative accuracy of 3 to 5 centimeters if we measure something, some distances from the object. In a general one, I would say up to 10 centimeter absolute accuracy. So in a global idea where our model is. But in our case, we use ground control points, we improve the accuracy. The model should be within 3 centimeters of accuracy. Next step is our third step. So finish the bundle. We finished the bundle adjustment, we finished the orientation. Now we are in reconstruction step, and I would like to speed up the processing and just reconstruct our 3D mesh in a high level accuracy, full texture, and let's downsample the model to, let's say, 2 millions of triangles. It's more than enough because it's a small site. Okay, I don't need point cloud here. I don't need true orthophoto. That's why those are deselected, and just click on OK. And we are already creating 3D models from video frames, which are also orientated with the help of Apertex. And see you in a few minutes with the results. Okay, and we are back. Here we can already see our reconstructed 3D models. So if I see from the camera positions, looks like to me like a decent 3D model from which I can easily vectorize out CAD data. Beside CAD data, here is super important to know that you will get even more than you actually needed. For example, here you can clearly see that some power line cable is running above these heat pipes. That here we have more power line cables, and this is everything very, very interesting and very important for the later documentation after you cover this with earth and asphalt and everything like that. So you can have really good idea what's under the asphalt also after 5 years or something like that. Okay, and this was a quick introduction how to calculate 3D model from videogrammetry data. Let's go back to live presentation in the webinar. Okay, so hopefully it was interesting workflow for you. We go pretty detailedly in everything, but now you have recorded. If you will try by yourself later, now you definitely know how to do it. And you can probably see on my back screen the same model here. So in a real time, let me turn also the camera positions that you can see from which perspective those were recorded, and know what's special about this and also special about our 3D survey. Once you have this model, you can go to CAD tab, you can create a new layer. So heat pipe, similar than you are doing this maybe in AutoCAD or similar CAD tools. Here you have all in a single software, and you can go to draw line tool. You can even add point on vertex, and you are able to start vectorizing now 3D CAD data. Okay, like that. And what's interesting, even when you are doing this in a 3D, you can see detailedly those positions also on a 2D images, and you can correct those positions if you would like to do it. Okay, and this is similar as you would measure this with a GNSS device in the field. You can similarly measure those 3D positions here on a 3D model. Okay, and as I mentioned before already on a video, you're not just mapping here 5 to 10 points, you have here the entire area, so everything what you need and even more. So if you later on need to know how deep this is, you can go here to measuring tool, and you just select the height, delta height, and you can snap here where the asphalt was, and you can see, okay, this is 1.43 meters deep. So after, or let's say, how high is this? The difference, so 0.45, and to terrain level 1.03 meters. So, and imagine after 5 years, when is this everything under earth, everything under asphalt, you can always go back, check your model, perform your measurements, and observe what's under the earth. So it's a super, super powerful documentation tool, I would say. Okay, cool. So we are right on time. We're close to our webinar, so we try to present you all this in the best way. Hopefully we did it, and now it's definitely a good time for questions if there are some. Before we go, Julia, what do you think? So did you like what you saw?
I loved it. Yes. Yeah, I also tested it myself, like the whole workflow, but with Reach RX 2, again, the new device we have, and worked just fine. So you have really nice documented like recommendations on what settings to use in the app on your laptop. So I figured I was pretty happy about it. And yeah, I'd say that it's pretty impressive, and I agree with you that it's super handy when you can have this, I don't know, I'm not sure if I can use the digital copy word in here, but well, pretty much have this really great, I don't know about this, the model for measurements, which is, yeah, amazing. So
I fully agree with you. And maybe just a short note. So all what you saw right now, you can find also if you go on 3Dsurvey.si webpage, and then go under the product and oops, product. Oh yeah, very good. No way. Tricky, but no. Shit. Okay, I will click the product button and RTK Videogrammetry, and I also recorded this bug for our web production company. And you have here the RTK Videogrammetry model. If you just go down, you get all the descriptions, you come to the department, what you need to get started. So you have which hardware you can use, where you can download all the instructions in a PDF. You can download SiteScan app on an APK. It's not on a Google App Store or something like that. You need to download it here. You have link to the entry app and all the short instructions how to do it. So you saw the Ivan Jean how he was holding the device. He was pointing a bit down. You don't want to have too much of horizontal view with a lot of sky and everything. You need to have focus what you are mapping. Don't run with this, okay? Go slowly because we are writing positions in the frames and all this stuff. Definitely there is a bit of expertise, but then at the end you can achieve great results. And here is also the complete descriptions about the Emlid and so on. Okay, so you're not alone. You have here our webpage, and of course support at 3dsurvey.si, another contact which can help you to improve your results then later on. Okay, and I believe we are ready now for questions if we have some of them. And yes, I can start with this one. Okay, so Kevin had some issues with the screen view, so with the PPT. So for the ones, if someone has some issues, we record the webinars. Definitely recording will be sent to you via email, probably tomorrow. And later on, you will also have the recording on our webpage. Then Yurai has another question. Hi, I have problem with testing 4.0 right now. I have error message and CUDA errors, advanced reconstruction. What do you think? Okay. I'm not sure if you're testing the videogrammetry or standard photogrammetry example, but looks like it's connected with the graphic card driver. 13, yes, maybe just upgrade the graphic card drivers. This is the first step. What you need to do later on, contact us if this is not working. Okay. So then the second question, Svetlozar, is videogrammetry an appropriate method for capturing and analyzing? Just a second to extend my view. Analyzing trees in a site survey. Okay, interesting. Yes, you could try to do that. If you mean trees, you can try to do that. Usually, if you're in the middle of forest or something like that, we always suggest to use a laser scanner or a drone lidar or something like that, which performs better in most cases, or or maybe a SLAM devices. But if you have a smaller site, feel free to use it also with the videogrammetry because it's the best starting point, cost efficient. What I suggest you, it's great if you start maybe on an open area where you have good position, good accuracy of the position, and then when you are moving in between trees, you will see that accuracy is going down, and if you come back out from the tree areas and you get the accuracy back of your mobile phone with a RX device, we can all handle this. Okay, so every frame has written what kind of accuracy is beside, and if it's more accurate, we take it as a more important. Okay, but of course there are some limitations, so it's much easier to work on the open areas. Okay, maybe Julia, you can add how much can handle the device. I don't have, what I know about the Emlid is that we get really quickly this information. So when the accuracy change, and this is super important because with some devices you go in the house and you see 1 centimeter accurate, accuracy, but this is just not true.
Yeah, well, it's like, of course, there is no just one list of, I don't know,
yeah, it's difficult.
Yes, like when, when you get what solution. But yeah, as I mentioned, so again, for the new device, so it's like all band support. So it overall helps you to work in more challenging conditions in more abstracted sky view. Another method is like, well, the final answer always depends on your exact location. So only going there with the device can help you tell it. But yeah, overall having the view partially obstructed is fine. What I also think of that is that, well, like the whole technology here, it's really nice to use GCPs. So if you have abstracted view, you can still go through it, you can still have pictures, and it's nice to have GCPs in more clear locations. It'll help you get it all together, it'll help you get the better result overall. So yeah.
Okay, thank you, Julia. Another technical question. So does the RX2 EMU improve the accuracy of the survey without observing GCPs? Okay, so of course, yes. So if you don't use the ground control points, it works the same way. We use the telemetry data from frames for the orientation, and this definitely helps us a lot. If you compare, because of course you can create also video without any external device, but then we have no information where those frames are. And if we have the external RTK antenna on it, it helps us first to pair the right frames, and secondly, orientate them and scale the model on the right position. If you use GCPs in addition, you just improve this accuracy. And even when you are doing the orientation with GCPs like you saw in this presentation, we take both information. So we take the telemetry from the frames and we take the GCPs, and this is then the strongest model. So yes is the answer. Okay, next question. We can buy the model. We can buy the module of videogrammetry. We can buy the model of videogrammetry. Yes, good question. So RTK Videogrammetry is actually a special part of 3Dsurvey, and you can buy it on a subscription based. I believe it costs 50 euros per month. So you buy it when you need it. When you don't need it, you don't need to pay for it. So you need actually a perpetual license and additionally RTK Videogrammetry model, or you buy a subscription of 3Dsurvey and additionally model of videogrammetry for 50 euros per month. I believe now Black Friday is coming and there are some special promotions will be there, like buy one get one. So if you buy 1 month, you get 2 months of videogrammetry. So worth to wait it a few more days or 1 day. I don't know where the Black Friday is. It's close to us. Okay, the next one. When I go filming a sample space one way, is it good idea to do it second time, stand back to get better result? Okay, Arthur, very good questions. Depends what you are doing, but there are bothly some beneficials. So once, in most cases, it's faster and easier just to go a single direction over it, because in this case you will 100% get good matching results, because there is no second line that could be misaligned to the first line. Okay, so as you saw it in this video we've been doing, we just go one way down and record everything, and in most cases this is the most effective and the safest version. If you would really like to have really detailed 3D models, because this model looks perfectly from those perspectives you were recorded, okay? And if you would like to have a nice and really detailed models, of course, then you need to go also the second time back, but try to keep in mind the idea that drone mapping is working, okay? So move a bit away from the first line, get probably the similar perspective than with the first line, because in this way both frames for two positions can match in between. So for example, if you will go one way down this way and then rotate yourself and go back the other way, this is too hard for algorithm and you're not going to get good results. So it's better in this case go forward one way and backward the other way, so that you keep the camera positions always in the same perspective. Okay, but definitely check it out, and yes, you will see, and contact us if you will need help. Okay, next question from Kevin. Can you confirm whether you're using the most accurate location? I've used other systems that use the mock location for fewer decimal places than the RX can provide. Okay, what I can confirm it that the benefit from Emlid is that we get immediately this information about the accuracy. Okay, so if the accuracy is running down, and we have really nice example when we were standing close to the building facade, we had like 25 centimeter of accuracy, and as soon we opened, we move away from the building, the accuracy goes to 1 centimeter, and then we can just handle this really nicely. So I can confirm this one. We were satisfied with most of the old tests we did with the Emlid, and yes, nevertheless, here you should also have all the white papers we recorded from every device, so feel free to download it and compare it. So we did an independent test what accuracy we were able to achieve, and yes, I believe I can agree that the Emlid handles this very nicely. Julia, would you like to add something with this one?
No, I'm not sure. Yeah,
okay.
It's really cool you have this comparison. I think I'll take a look as well.
Okay, then the next question, where did the app on the phone come from, Emlid or 3Dsurvey? So the phone on the app was actually the 3Dsurvey SiteScan app is from 3Dsurvey. Then another app which we've been using to connect the Emlid device with the correction was N-Trip. So actually you use both those apps. First you run the N-Trip, connect, first time you need to predefine it to your connection centers and so on. Next time you just connect it to corrections, and then you start the 3Dsurvey SiteScan and it works. Okay, Julia, do you prefer also any other apps to run?
No, I'm also like to use the mock location. I was also using the Lefebvre, this N-Trip app. Yeah, and well, it's indeed like pretty easy. So you just pair the devices via Bluetooth, and later on you'll just use this exactly the same settings for configuration. Yeah, and here technically you have options because it has its own N-Trip client to configure N-Trip credentials. But again, yeah, from the Reach RX, Reach RX2 side, we also have Emlid Flow app, which is like available both for Android and iOS. You just download it from Google Play or App Store. And yeah, there you can also connect to the device, also use N-Trip client to get corrections. And well, yeah, as I mentioned, the position via Bluetooth is streamed automatically. So yeah, there is no need even to configure something additionally here. Again, later on, you just pair the devices via Bluetooth and get the data in EMEA format, which is standard.
Okay, very good. Thank you, Julia. Another interesting question for you: is the RX and RX2 the only Emlid device compatible with your videogrammetry?
Oh, well, I'd say that here the main thing is just like this whole system, the whole setup with the handle, because on the handle, yeah, you can place only Reach RX and Reach RX2. Overall, our other devices, again, the devices I mentioned today, Reach RX4, Reach RX4 Pro, they also are capable of Reach RX3 as well. So they all are capable of streaming position via Bluetooth. So on this point, there is no any blocker. I'd say that it's just here the question of the setup itself, and the fact with the Reach RX and Reach RX2 is that they're small, they're lightweight, you can place them on this handle and just easily work with them. Plus, yes, the configuration I don't know, process is super minimized. So again, you configure just correction input, position streaming is already enabled. So with this point, yeah, it's just, I don't know, the easiest, the smoothest way to make it work.
Okay, very good. Okay, then Andre is saying us, hi, Julia and Marko. So thank you, Andre. Thank you for coming to this webinar also. Samuel is asking, is it possible to buy the equipment directly from the website? So on 3Dsurvey website, we have a link to Emlid. And Julia, can you buy Emlid directly from website or through partner network?
We have also a store, like online store, and we do have a wide network of our partners as well. So yeah.
So both is possible. Okay, and then last question from Deon, super interesting. If you have an area 100 per 100 meters, what is the best process to capture? Okay, so if you have areas like that, I would suggest you like the W approach. You go forward, backward, and forward, and you repeat like that. And you're pointing always in the same position. But I would mention here again, so it's the best possible options are actually the best possible options are definitely ideal for this, like you see like here the pipelines, so not so brighter areas. So if we have like 100 and 100 or 200 per 200, use drone if this is possible. I know it's not always possible to fly over it, but yes, if you need to do it like that, it's not the perfect scenarios for this technology. But in this case, try to do it like a W or something like that, okay? We also have some instructions how to map this if you browse on our web page, okay? Okay, and Amy just mentioned me to scroll down because we have also, okay, so we have answer here. Can I order each online from Emlid store? Yes, you can browse the Emlid store. So here's the link. We are ready for your question already before, okay? Thank you, Amy, for helping us. And Julia, I believe we are close to the question and answers. I think we covered nicely everything. Before we finish, would you like to add a few more sentences to this webinar?
Oh, well, I just wanted to thank you and, well, thank everybody for coming. For me, it was also pretty interesting to watch it with your tips, tricks, comments, and all this stuff. So I do believe I learned also a bit more about 3Dsurvey, which is awesome. So yeah, thank you for this. Thank you for the demo. Was cool to be here.
Okay. Thank you, Julia, also. So it's always great to join power with other companies, with other great companies like Emlid and so on. Hopefully, we will still continue working together on some other projects. And also, thank you, audience, for being part of this webinar. And Wish you a great day, and we are back in December webinar. Okay, follow us on Instagram, Facebook, YouTube, webpage, everywhere. A lot of interesting topics are delivered on a monthly basis. Thank you again. Wish you all the best. Bye bye.
Thank you. Bye.